All right, so now let's take a look at some derivatives of the other functions. We got the power rule. That's like one of the most common ones you're going to take the derivatives of. And don't be scared by this entire list. This is something, especially on these guys, we'll probably spend a little bit more time like learning about those derivatives when we do the inverse functions. So don't be too scared about intimidated by this. I would say in the beginning, I mean, basically, eventually you're gonna want to memorize all of these derivatives. You have to have these memorized. There's just no choice around them. But I'm gonna highlight a few things here. First of all, something about e to the x. E is the base, like it's the exponential function. Has this interesting property where if you take the derivative of e to the x, it's unchanged. So if I have f of x is e to the x, the derivative of that is also e to the x. So it actually doesn't change. That's kind of an interesting one about that. If the base were a little bit different, let's say it were a to the x, okay? And one of the things, I can't prove it to you now, but like basically the derivative of this guy is it's almost the same. It's like it doesn't change, except you have to multiply by the natural log of the base afterwards. And now you can think of it as memorizing this way. If you know e is the natural log of e is just 1, so that's why it doesn't show up in this one, right? So a is a different base. So for example, if you had 2 to the x, the derivative of that would be 2 to the x times natural log of 2. Okay. Once we know some other properties of derivatives, I can actually prove this to you from this one, but some of these can be proved just by the limit definition of the derivative. Okay, how about natural log of x? If I have ln of x, right, the derivative is going to be 1 over x. So it's kind of 1 over that thing. Now, remember, natural log is log base e, so if you have it as log of base a, then what happens is the derivative is still the same thing, except instead of multiplying by natural log like you do for exponentials, you divide by the natural log of the base. So if you do log base 10 or a different base log, then you have to divide by the natural log of that base. And then these two are probably the main ones to really focus on initially. It's kind of an interesting part is that the derivative of sine is cosine, and the derivative of cosine is sine. It is negative sign. There's a negative sign in here when you're doing that. And then here's some of the other ones. Tangent goes to secant squared. Cotangent goes to negative cosecant squared. Secant goes to secant. These are just things that you'll just kind of have to memorize. We're going to derive some of them where they come from once we know other properties. But for now, you're just going to have to just say like, oh, if you see those kinds of functions, you are literally just going to memorize what the derivative of them is. Okay. So you'll see some examples. So you'll go through some of the examples next. We'll do a few examples of combining them, of how you take those derivatives. Now we're going to look at some derivatives of other functions. So the derivative of e to the anything, or e to the r, is just e to the r. So the derivative of this, I leave the 6 alone. The derivative of e to the r is just e to the r. That's one of the easier rules that you're going to deal with. Okay. For this one, for ln, the derivative of ln is 1 over x. So I leave the 2 alone, because the 2 is just in front as a constant, times 1 over x, minus the derivative of x by power rule is just 1. So this is 2 over x minus 1. This one I have to use a little bit of log rules. I could use chain rule, but one thing I know is, because the problem is this 3 and this x squared business. Like, I only know the derivative of ln of x at this point, so I'm not using chain rule or product rule or any other rule that you're thinking of. And so here I have to use my rules of logarithm. First, I can separate the 3 and the x squared to ln of 3 plus ln of x squared. And then the other rule is that when I take natural log with an exponent, the exponent comes in front, right? So now we take the derivative of this. This is just a constant. ln of 3 is just a number. It's a very weird number, right? It has lots of decimal points, irrational and everything, but it's still a number, okay? And so so the derivative of that is going to be 0. So really only got to worry about this part. This is 2 times the derivative of ln x is 1 over x, 2 over x. For this one, let's look. These are all constants. Like, these are all numbers. There's no t anywhere in here. So the derivative of this is just 0. By constant, I mean it doesn't change. ln of 17 is just a number. Again, these are all weird numbers. Actually, sine of pi over 2 is just 1, by the way. But other than that, they're just numbers. They're constants. And the derivative of constant is always 0. Okay, here's exponents that are not to the x. And this is a rule that sometimes teachers don't cover or you don't use very often. So there's a trick to sort of doing these that requires chain rule. But for now, we're just going to remember the rule. Whenever I have a to the x, the derivative of this is a to the x natural log of a. Now, eventually, later on, we can look to see through chain rule why this works out this way by using e to the x. So like e to the x, this rule applies because it's e to the x ln of e, but ln of e is just 1, right? And so it just becomes e to the x. So we're always familiar with the e to the x rule. But if the base is different than e, then we gotta always multiply by natural log of a. So in this case, we're gonna say f prime of x is equal to 2 to the x ln of a plus 3 to the x ln of a. Because the derivative of those are just, the core function stays the same, but I gotta multiply by the natural log of, not a, but 2 and 3. Natural log of the base. Okay. Derivative of sine and cosine. Derivative of sine goes to cosine theta. This is important to remember. In cosine theta, when I take the derivative, it goes to negative sine theta. So the ones that start with c, some people like use as a rule. If it starts with c for the trig functions, I put a negative sign when I do the derivative. So this becomes sine theta. Derivative of sine is cosine theta. That's 9 cosine theta. Derivative of cosine is negative sine theta, so it's minus 10 sine theta. Okay. And here we're going to be mixing a bunch of these. So h prime of t, e to the t, the derivative of e to the t is just e to the t. Derivative of sine is cosine. And derivative of cosine is negative sine, so it'd be minus a negative sign or plus sine t. Just change the sign like that. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.